Let's do an example about estimating the instantaneous velocity. So here are the directions. Consider the following position function. Complete the table by filling in the average velocities. Then make a guess about the value of the instantaneous velocity at time equals 1. So our position function here is given by s of t, and that's negative 16t squared plus 96t. And then if we look down at this table we're given, we see that in that top row we have different time intervals. And if you look at those time intervals, you'll see that they're getting smaller and smaller. They're getting tighter around the point time equals 1. And then in the second row we have blanks to fill in the average velocity for each of those time intervals. So let's start by calculating those average velocities and filling them into the table. So we need to remember how to calculate the average velocity. Now, if you remember, the average velocity is the change in position over the change in time. Okay, so often we use this notation, average velocity. Okay, and that's going to be the change in position, which is going to be s of t1 minus s of t0 over t1 minus t0. And t sub 1 and t sub 0 just represent the two different time points that I'm looking at. Okay, so let's start calculating. To speed things up a little, I've gone ahead and calculated most of the function values for us. So if you had to calculate those on your own, of course, you would just plug them in to the function s. So let's start with the interval 1, 2. This is from time equals 1 second to time equals 2 seconds, and let's calculate the average velocity over that interval. So my formula says it should be s of 2 minus s of 1 over 2 minus 1. And I've already calculated these function values. So that's 128 minus 80 over 1. And if you work that out, you get 48. Okay, so we need to do all these other intervals as well. Okay, so next we have 1 to 1.5. Okay, so that's going to be s of 1.5 minus s of 1 over 1.5 minus 1. And that gives me 108 minus 80 over 0.5, which if you work that out, it's 56. All right, and we keep going, 1 to 1.1. So notice these time intervals are getting smaller and smaller and tighter around 1, which is the point we're interested in. Okay, so s of 1.1 minus s of 1 over 1.1 minus 1. Okay, so that gives us 86.24 minus 80 over 0.1. which equals 62.4. All right, and then we've got 1 to 1.01. Okay, so that's position at 1.01 minus position at 1 over 1.01 minus 1, which is 80.6384 minus 80 over 0.01, which is 63.84. And last one, 1 to 1.001. Okay, so really tiny interval now, really tight around time equals 1. Okay, 1.001 minus 1. Okay, and for the sake of time, I'm just going to write the final number, 63.98. Okay, let me quickly put these in the table for you so you can see the trend. Okay, so we had 48, 56, 62.4, 63.84, and 63.98. Okay, so we've done the first part of the problem. We've completed the table by filling in the average velocities, and to do that we simply used our average velocity formula. But now the next thing we have to do is make a guess about the value of the instantaneous velocity at time equals 1. Okay, so what does the instantaneous velocity mean? Okay, so the instantaneous velocity at time equals 1, it just what it sounds like, the velocity just at that single instant. So far I just have average velocities, the velocity over an interval of time. But I want to find the velocity just at the single instant time equals 1. Okay, so how would I do that? Could I do that using my normal average velocity formula? So could I do this, for example? Look at the interval from 1 to 1. What would that get me? I get s of 1 minus s of 1 over 1 minus 1. Well, that doesn't work, right? Because I get 0 over 0. So I see that this is not the way to figure out this problem. Okay, so in the future we'll actually learn a way using calculus to figure out the answer, the exact answer to this problem. But for now, we're just going to make a guess. And we're going to make that guess based on the behavior we see from this table. Okay, so let's look at it just one more time. So look at my time intervals. They're getting closer and closer to 1. They're getting smaller and smaller. And I see my average velocity is following a trend, right? So 48, 56, 62.4, 63.84, 63.98. So what are those average velocities? What do they seem to be getting closer to? Or if you imagined making a even smaller interval, like if I went from 1 to 1.00001, what do you think the average velocity might be even closer to? Well, to me, it looks like it's approaching 64. We can't really know that for sure from this table, but it's a good guess at least. So we're going to guess 64 is our final answer for the instantaneous velocity.